We're going to wrap up our last lesson on volumes and areas by talking about, this time, volumes by cross sections. If you'll look here, I've kind of got an example of a loaf of bread. If you think of that as a rectangular prism or a box, if you slice it, each one of those shapes would be a cross section, and that would make each cross section be in the shape of either a rectangle or a square. So that's what we're going to be looking at now. The two main cross sections that you normally see on the AP exam would be cross sections that are squares and then cross sections that are semicircles. And so I've got examples of both of those drawn here. If you look here at the square cross section, they're going to have to tell you what axis that you're going to draw this perpendicular to, whether it's perpendicular to the X or Y axis. And then they're also going to tell you what shape you're going to use. And here we're using a square. In the next example, you can just kind of see what a semicircle cross section would look like. And then just imagine as you get down here, you're going to have different size semicircles. And here at the end, you'd have smaller semicircles. And so that kind of gives you an idea of what you're doing. You're building from a base, and you're drawing perpendicular to that base your different cross sections. Alright, let's start with a fairly easy one. Let's let the area bounded by y equals x squared and y equals 4x be the base of a solid formed by cross sections perpendicular to the x-axis. Notice they tell you what you're perpendicular to, and formed by using squares. And what we want to do is find the volume of that solid. So here's what we're taking. We're taking this area here. So let's kind of enlarge that. And what we're going to do is we're going to draw squares that are going to be perpendicular to the x-axis. So imagine that being drawn this way. And those shapes that are going to come up out of the board at us are going to be squares. So we'll try to draw one here. So imagine that being actually up off of the screen and in 3D. And you're going to have different size squares. When you get down here, you're going to have a much smaller square. Okay. And so what I want to do then is I want to find the volume if I use those cross sections that are squares. To find the volume by cross sections, what you're going to do in general, the volume is going to be the integral from A to B, because we're going to add up a bunch of cross sections, and you're going to take the area of your shape, whatever your cross section would be, whether it's a square or a semicircle, and you're going to multiply that by the thickness. And as always, your thickness is either your dx or your dy. So in this case, because I'm drawing these perpendicular to the x-axis, then that's going to be my thickness, and it's a dx. Whatever your axis is going to be perpendicular to, then that is the variable that you're going to integrate with respect to. So if you're perpendicular to the x-axis, it's dx. Perpendicular to the y-axis would be dy. So looking at this problem, we do need our points of intersection. These are going to intersect at 0, 0. And then you've got y equals x squared and y equals 4x. And those are going to end up intersecting at 416. Since we're perpendicular to the x-axis, we're going to do this as a dx problem. Volumes of cross sections do not always get a pi like disc washers did, okay? So keep that in mind. So my volume is going to be the integral. We already know it's a dx problem. And we're going to go from 0 to 4. That's my x points for my integration. And then I'm going to use my area of a square, which is s squared. So then I just need to take the side and square it. Well, the side is going to be the distance between your two curves. So that would be like here. And so that side would be top minus bottom. It's a dx problem. So we do top minus bottom. Top is 4x minus bottom x squared. And that would be your integral that would find your volume. All right, our last example. We're going to take the area bounded by y equals the square root of x and y equals 2. We lost our number there. And the y-axis. And we're going to make that the base of our solid. And we're going to use cross sections that are going to be perpendicular to the y-axis and find the volume. So this time, again, let's kind of enlarge that. If I bring this out, and this is going to look like this shape. And what I'm going to do is I'm going to draw cross sections perpendicular to the y-axis that are going to be semicircles. So again, imagine you've got just different size semicircles that are going to be your shapes that are going to make this thing 3D. So to find the volume, because I'm perpendicular to the y-axis, I know it's going to be a dy problem. And my limits of integration will be from 0 to 2, because we're going this way to find my limits of integration as a dy. And then my area is the area of a semicircle, which is 1/2 pi r squared. So I need 1/2 pi and then the radius squared. Now normally we put our 1/2 pi out in the front. Now to get the radius of my semicircle, if you look at my picture here, here was one of the semicircles. Alright, if I do, since it's a dy, a right minus left, that's not going to give me the radius, that's actually going to give me the diameter. So if I take the right, since it's a dy, and I had y equals the square root of x, then that means x equals y squared. So if I take right, y squared, minus left, which would be the axis, that's my diameter, so I need to take that and divide it by 2. You're going to find on a lot of the semicircle problems, you're going to end up doing like a right minus left divided by 2, a top minus bottom divided by 2, because the distance between those two curves is normally the diameter.